So section 5.2, part 2, we're not going to go over any new integration rules, but we will learn 3 new techniques. The first one is whenever you have a problem where you have a bigger exponent in the numerator than you do in the denominator, you're going to use a long division to simplify this. So this first technique is going to be a long division. And you're going to use long division just to simplify the problem before you actually integrate. So I'm going to go ahead and divide 2x squared plus 7x minus 3, all being divided by x minus 2. Now you can do a synthetic division on this one because it's linear. You could isolate x minus 2. But I'm going to just use long division because long division always works. But you're welcome to use synthetic division if the problem allows you to. Alright, so I can divide this by 2x. It's going to be 2x squared minus 4x. Then you go ahead and switch the signs, or you're same thing as subtracting, so this becomes negative, this is positive. Alright, and let's see here. This crosses off. So now I get 11x, and then this will be plus 11. This will be 11x. I forgot to bring down the minus 3. Oops. This is going to be minus 22. Subtract the signs, or subtract, which means switch the signs. This crosses off. This is going to be 19. So it's going to be plus 19 over x minus 2. So this divides into being 2x plus 11 plus 19 over x minus 2. So this technique is you use long division to divide this, and this is your answer. So now you're going to integrate this. So you would integrate this now term by term. So integrating this is going to be the integral of 2x plus the integral of 11 plus the integral of 19 over x minus 2 dx. And the reason I'm going to integrate these is separately is that they require different rules. These two require the power rule. This is going to be 2x squared over 2 plus 11x. But this one requires a u sub. And I'll combine everything at the very end so you'll see how this all simplifies. So doing this one separately, I have to do a u sub. This is going to be x minus 2. du is going to be dx. And so this factors as 19 over u du. This 19 is a constant. I can factor it out, so it's going to be 19 the integral of u to the negative 1 du. So this antiderivative is going to be 19 ln of u. And then I plug back in what I set u equal to, which was x minus 2, so it's going to be 19 ln absolute value of x minus 2. So this integral is 19 ln of x minus 2. So I can put my answer as simplified out. This becomes just x squared. This is going to be 11x, and this is going to be plus 19 ln of x minus 2 plus c. So after you do long division, you integrate what you have left over, and each is going to require a different rule. These two are the power rules, and this one required a u sub, and along with the ln integral. Alright, next example. Now notice on this one, I can't do a long division because if I were to expand this, this would be x squared plus 2x plus 2. So I can only do long division whenever I have a bigger exponent in the numerator than I do in the denominator. So this one is going to be, well, if I try to just do a regular u sub, I would let u equal x plus 1, and then du would just be a dx. Notice I haven't accounted for this 2x up here. U is going to be this part of the problem. Dx is just going to be du. But I don't have this extra 2x accounted for. So this technique is it's called a U manipulation. This U manipulation, I go ahead and I solve for x. So that means that x is the same thing as u minus 1. All I did was subtract this 1 over. And so I'm going to replace x up here with u minus 1. So my integral is going to be a 2 parentheses u minus 1 all over u squared and then du. So I'll explain how I got from here to here. Inside the parentheses, x plus 1 is what I let u equal, so it's u squared. Du just replaces dx, so it's over here. And then this 2x, I keep the 2, but then I replace x with u minus 1. So the whole idea of a u sub in general is to put everything in terms of u, and this u manipulation accounted for this extra x. Okay. So now from here, I go ahead and simplify this. I go ahead and factor out this 2, and I integrate u minus 1 all over u squared du. Now notice at this point, I have to simplify even more, because now I have 2 terms in the numerator, so I can split this up as u over u squared minus 1 over u squared du. And then simplifying this some more, I have 2 integral of 1 over u minus 1 over u squared du. And then I go ahead and rewrite this so I can see the exponent. So this is going to be the integral of u to the negative 1 minus integral of u to the negative 2 du. Alright, and then I have to apply now the appropriate integration rule. The very first one is u to the negative 1, so it's going to be 2 ln absolute value of u. But this one, this is u to the negative 2. I can go ahead and use the power rule. Because the power rule says as long as the exponent is not negative 1, I use this rule. So this exponent is not negative 1, so I apply the power rule, which is adding the power by 1, so it's u to the negative 1 over negative 1. Over here on the side, I'll show you u to the negative 2. The power rule is u to the negative 2 plus 1, negative 2 plus 1, and then the big plus c at the very end for my integral. That's the wrong color. Let me make sure I'm consistent here. Alright, so simplifying this more. I replace u with what I let u equal, which is x plus 1, so my answer is going to be 2 ln absolute value x plus 1. These two negatives cancel off, so it's going to be plus 1 over u to the negative 1 becomes 1 over u in the denominator, and so I let x equal plus 1 and then plus c, and that's my answer. So the general idea for a u manipulation is you do a u sub, and then you just replace, you solve for the unaccounted for variable, and integrate as needed. This one required an ln, this one just required the power rule, and put everything back in terms of x. Alright, and one last one. So this one's going to involve finding the area under the curve from here to here, from 1 to ln of e squared, or sorry, from x equal to e squared. Alright, so in this one, it's going to be x squared over 2 all over x. These are going to be my upper and lower limits, so it's going to go from 1 to e squared dx. And I have a bigger term, bigger power in the numerator, so I could use long division, but since I'm only dividing by x, I'm just going to simplify. So the last technique is to simplify the integral. To simplify the integral is kind of like we did at the very end of the last problem, and that's just going to be splitting this up. This is going to be x squared over x minus 2 over x from 1 to e squared dx. So this simplifies to just be x minus 2 over x from 1 to e squared. And then I can just go ahead and apply the appropriate power rule. This x is the same thing as x to the little invisible 1. And so I can add the power by 1. So x squared over 2. And this 2 over x is the same thing as this constant over x. So it's going to be ln. So it's going to be 2 ln absolute value of x going from 1 to e squared. So this required the power rule, and this one required the ln integral. And then I go ahead and plug in my upper limit, so it's going to be e squared squared all over 2 minus ln, 2 ln absolute value of e squared minus, and I plug in 1 squared over 2 minus 2 ln of 1. And then from here it's just a matter of simplifying. E squared, so power to a power you multiply, so it's e to the 4th all over 2 minus the ln and the e cancel off. They're inverses, they undo each other. So ln and e based on this property just becomes 1. But this exponent drops down. So really what I have is 2 times 2, so this is going to be minus 4, minus, this is going to be 1/2, minus, and then ln of 1 is equal to 0. So this just becomes 0. So really just what I have is this. So last little bit, I guess I can simplify and find common denominators, and this is going to be e to the 4th all over 2 minus 8 over 2 minus 1 over 2, and that's going to be e to the 4th all over 2 minus 9 over 2, and that is my answer. So integration here is just, the technique is to simplify the integral, and then from there it's just a matter of simplifying the answer through. In class tomorrow I can explain this step a little bit further. If you got lost or maybe you didn't really catch what I did, I could explain how this turns into 4, and that's it for the video.